In this video, we're going to talk about how to identify key features of quadratic functions in standard form. So standard form of a quadratic function is f of x equals ax squared plus bx plus c. And based on this equation, we can actually identify some of the key features of this quadratic function. The y-intercept will be at 0, c, because remember the y-intercept occurs where x equals 0. Well, if we plug in x equals 0 to this equation, notice that we'll get f of 0 equals c. The x-intercepts can be found by setting the function f of x equal to 0 and solving for x. The equation of the axis of symmetry will be x equals negative b over 2a. Remember, since the axis of symmetry passes through the vertex, that's also going to be equal to the x-coordinate of the vertex. So I kind of mentioned that, we're going to find the x-intercepts by setting f of x equal to 0 and solving for x. So remember, that's going to require us to basically solve a quadratic equation. Because if we take f of x equals ax squared plus bx plus c and set it equal to 0, well, we're going to get a quadratic equation in standard form, ax squared plus bx plus c equals 0. And remember, we actually know three different ways of solving these equations. You can graph, and when you graph this equation, the x-intercepts will tell you the solutions. You can also solve this type of equation by factoring. Remember, you can factor it depending on whether a is 1 or a is not 1. And you'll then finally set each factor equal to 0 and solve for the values of x. You can also use the quadratic formula by plugging the values of a, b, and c into x equals negative b plus or minus the square root of b squared minus 4ac over 2a and solving for the values of x. So just to summarize, here are the key characteristics of a quadratic in standard form. So x squared plus 4x plus 3 is a quadratic in standard form. Notice that it has two x-intercepts at x equals negative 3 and x equals negative 1. So if we actually set this equation equal to 0 and solve for x, we will get negative 3 and negative 1. The vertex is going to be at negative 2, negative 1. Notice that that x-coordinate of the vertex is going to be equal to negative b over 2a. And also the axis of symmetry is going to pass through that vertex. So let's identify the key characteristics of the parabola represented by f of x equals x squared minus 2x minus 8. So the very first step in doing these problems will be to first identify a, b, and c. So I know that x squared does not have a coefficient written in front of it, but remember, whenever we have that, that means that there's an implied 1 there. So let's go ahead and write in that coefficient of 1. So our a is going to be 1, b is going to be negative 2, and c is going to be negative 8, right? Because this is ax squared plus bx plus c. So what we're going to do now is we're going to identify the y-intercept. Well, we already said the y-intercept is going to be at 0, c, so we'll say the y-intercept is at 0, negative 8. The x-intercepts can be found by setting this function equal to 0. So we have x squared minus 2x minus 8 equals 0. And then if we solve for x, we can actually find the x-intercepts. Well, I really like to solve quadratic equations by factoring, so I'm going to actually do by factoring. Since a is equal to 1, it's actually not going to be too bad to factor this, right? We're going to be looking for factors of c, so factors of negative 8 that are going to add to negative 2. So since 8 is negative, I know that I need a positive factor and a negative factor. Since 2 is negative, I know that my bigger factor in all of these pairs is going to be negative. So the factors of 8 are like 1 and 8 and 2 and 4. Let's make all of the bigger factors negative, and then let's add these factor pairs together. So 1 plus negative 8 is negative 7, so that's not going to work. 2 and negative 4 is negative 2, so that is the correct pair. So I can write this as x plus 2 times x minus 4, and that is equal to 0. Well, remember, the zero product property tells us that means we either have x plus 2 equals 0 or x minus 4 equals 0. If I solve these two equations for x, well, on the left side, I'm going to get x equals negative 2. And then on the right side, if I solve by adding 4 to both sides, I get x equals 4. So these x values tell me my two x-intercepts. I'll have x-intercepts at negative 2, 0, and at 4, 0. So now it wants us to find the axis of symmetry. So remember, we said that the axis of symmetry will be at x equals negative b over 2a. So I'm going to use that formula to figure this out. So I have b is negative 2, so this is going to be negative negative 2, and that's over 2 times a, which is 1. Well, negative negative 2, that's just positive 2, so this is just going to be 2 over 2, which is equal to 1. So that is going to be the equation x equals 1. Well, we know that that's going to be the x coordinate of the vertex. How do we figure out the y coordinate? Well, remember that f of x is just basically y, right? So I could also write this equation as y equals x squared minus 2x minus 8. So if I just plug in 1, I get y equals 1 squared minus 2 times 1 minus 8. So that's going to be y equals 1 minus 2 minus 8. Well, that's going to be y equals 1 minus 2 is negative 1. Negative 1 minus 8 is going to be y equals negative 9. So that's how you can figure out the y coordinate of the vertex. Now I'm going to graph this function and verify all of the information that we just found. So this is x squared minus 2x minus 8. Okay, so we said that the vertex was at 1, negative 9, which is the same thing that we found. The axis of symmetry will pass through x equals 1. And let's see the x-intercepts. They are at 4, 0 and negative 2, 0, which is exactly what we found. And then let's check the y-intercept. The y-intercept will be here at 0, negative 8. So that is also correct. And notice that this parabola opens up, so the vertex will be a minimum. Okay, so I'm just going to circle that to let us know that the vertex is a minimum. So let's now work on this parabola. So let's identify the key characteristics of x squared plus 2x minus 4. So in this case, remember once again, my a is going to be 1, and then my b is 2, and c is negative 4. So it's going to have a y-intercept at 0, negative 4, because that's my value of c. The x-intercepts, well, I need to now set this equation x squared plus 2x minus 4 equal to 0, and I need to solve for x. So if you try to actually factor this equation, you'll notice that factoring doesn't work. So I'm going to actually need to use the quadratic formula. So that tells me that x equals negative b, so negative 2 plus or minus the square root of b squared, so 2 squared minus 4 times 1 times negative 4. And that's all going to be over 2 times a, so 2 times 1. So we have x equals negative 2 plus or minus the square root of 2 squared is 4, and then we have minus 4 times 1 times negative 4, so that's minus negative 16. Minus negative 16 turns into plus 16, so that's over 2. So this is basically negative 2 plus or minus the square root of 20 over 2. Remember, whenever we see a radical, we want to think about how to make it better. So if I think about the square root of 20, I can actually make it better by factoring out a square root of 4. So we have the square root of 4 times the square root of 5, and that's over 2. So this is going to now turn into negative 2 plus or minus 2 square root of 5 over 2. Well, everything has a common factor of 2, so I'm just going to reduce this fraction now. This is going to turn into negative 1 plus or minus the square root of 5. So that means that the x-intercepts are going to be at negative 1 plus the square root of 5, 0, and at negative 1 minus the square root of 5, 0. If you really want to, you can actually turn these into decimals. So let's go ahead and use our calculator to help us out with that. So we can do negative 1 plus the square root of 5. And that tells us 1.236. So you can say that this is going to be 1.236 comma 0, and then negative 1 minus the square root of 5. Let's go ahead and type that in. That is going to be negative 3.236. So we have negative 3.2360. Okay, so you can write it as a decimal if you prefer to do that. So the axis of symmetry, well, remember that's going to go through that negative b over 2a. Well, in this case, b is 2, so we have negative 2 over 2 times a, so negative 2 over 2, which is equal to negative 1. So the axis of symmetry will be at x equals negative 1. So if I plug in x equals negative 1 into this equation to get the y coordinate of my vertex, I'm going to have negative 1 squared plus 2 times negative 1 minus 4. Negative 1 squared is 1, so that's going to be 1 minus 2 minus 4. 1 minus 2 is negative 1. Negative 1 minus 4 is equal to negative 5. So my vertex will be at negative 1, negative 5. Let's actually go to Desmos now and make sure that everything we have found so far is correct. So we have x squared plus 2x minus 4. Okay, so we said that the x-intercepts were, you see at those decimals, negative 3.2360 and 1.2360, which is exactly what we found. The y-intercept was at 0, -4, which is the same as what we found. The axis of symmetry will go through x equals -1, and we can see that the vertex is at -1, -5. So that's all correct. And then also notice the vertex is the lowest point. So this vertex is going to be a minimum because this parabola opens up. So now you can go ahead and pause the video and try doing this example on your own. So I started off this problem by identifying the values of a, b, and c. So remember, a is that implied 1 that's in front of our x squared. So we have a is 1, b is 7, and c is -8. So when I try solving the equation x squared plus 7x minus 8 equals 0, I can actually solve this by factoring. So my two factors are x minus 1 and x plus 8. When I set each of these factors equal to 0 and solve for x, I get x equals 1 and x equals -8. So my x-intercepts will be at 1, 0, and -8, 0. Also, our y-intercept will be at 0, -8, because notice that the value of c is -8. So the axis of symmetry will be at x equals -3.5, because if I plug in negative b over 2a, I get -7 over 2 times 1, which is -3.5. If I plug in -3.5 to my equation, I get -3.5 squared plus 7 times -3.5 minus 8. So I went ahead and did that on my calculator, so that gave me -20.25. So that means that the y-coordinate of my vertex is -20.25. So now I went ahead and went to Desmos and graphed this function. So if I look at this, I get the x-intercepts at -8, 0, and 1, 0, which is what I found. The y-intercept is at 0, -8, like we found. The axis of symmetry will go through the vertex, and the vertex is at -3.5, -20.25. So that matches what we have here. And since this parabola opens up, this vertex is going to be a minimum value. So remember that you can identify the key features of a parabola from its equation in standard form. F of x equals ax squared plus bx plus c.